field lab is really about trying to enable farmers to understand how much pasture that they've got available. So it's using satellite data, a load of climate, weather data, and bringing that together in a model so that that can inform the decisions that they're making in terms of managing their grassland.
Management decisions around pasture are quite difficult, particularly with the change in the weather, how the grass is growing and the seasons. Last summer we had a really hot summer and the grass just stopped in one of the peak growing seasons. So it's having that flexibility to be able to adjust your grazing depending on the weather in particular, being able to then predict as best you can what may or may not happen.
This technology is about trying to come up with an easier, quicker way for farmers to measure grass. So at the minute, a lot of the measurement techniques might be slow, they're not always very accurate. Satellite data can give farmers a good overall picture of their whole farm, quickly and reliably and frequently. But some of the satellite technologies that are out there at the minute rely a lot on optical data, which relies on cloud-free skies. And like today, we have lots of clouds. That's not going to give us much. So the thinking behind this technology is about combining that optical satellite data with radar data that can see through the clouds and weather data, pulling all of that into a model that understands how grass grows to provide farmers with regular, accurate data on their grassland.
Having a bird's eye view of the pasture and pasture management, it gives whole field and whole farm coverage. Farmers are very time poor, so they need things to be available to hand when they want it and easy to use. And by getting that whole farm view and seeing how the grass growth is changing, I can actually change the order I graze fields and how quickly I move on from one cell to the other.
We've been doing a lot of field work to collect ground data to calibrate the satellite modelling. We measure sward height with a rising plate meter. We've used a device called a sun scan to measure the amount of green leaf area on the ground. And then we've also been cutting fresh samples and drying them to get dry matter.
Benefits of farmer-led research are that farmers are involved at the beginning, so what they get at the end of the project is something they have co-designed, worked with the researchers, and is actually of use, rather than being given a tool and say, here you go, this is useful for you, and you go, well, actually no, it's not.
Being able to co-design means that they can test so that we can get products to market incredibly quick, because you're making sure that you're always going to provide a solution that the farmers are going to use.
Having lots of different farmers involved in the project has meant we've got a real mixture of opinions, priorities, and each of them has their own needs and wants and what they're looking for out of this data. So having all of them input into this and getting the different opinions has been really good.
Using the technology, I see it as a way of saving costs, but getting more relevant information without having to walk every single field to get that measurement. I see a positive value on my business, on my grazing, health of the livestock, the biodiversity, or the way I'm managing the farm. Data from a project like this, if that adds value and gives me more information, then I'm going to make better management decisions.